So in the first video, we talked about prime factorization. We talked about the vocabulary of prime and composite, their definitions. We listed out the first 10 prime numbers, and we worked on our first factor tree for the number 36. Now we're going to do just a couple more examples of a couple different numbers that I want you to find the prime factorization of. And I'm going to start with the number 200. So when we start with 200, I want you to think of two numbers that multiply together to give us 200. I'm thinking of 2 and 100. Two groups of 100 is 200. So 2 is prime. I'm going to circle it, and then I can keep going. When I think of factors of 100, I'm thinking of 2 and 50. So 2 is prime. I can circle it and break down 50 even more. 50's factors can be 2 and 25. So I'm going to circle my 2. And still my 25 can break down into 5 and 5. 5 is prime, so I circle both 5s. And when I rewrite this in order least to greatest, 2 times 2 times 2 times 5 times 5, I've got my prime factorization. The last thing that we want to do is we want to write our prime factorization with exponents. And so because I have three 2's here, I'm going to do 2 to the third power times 5 to the second power because I have 2 5s. And so you can see my prime factorization there in exponent form, 2 to the third power times 5 to the second. And something I really want you to notice is that my bases 2 and 5 are in order from least to greatest. Remember that you could have picked different factors besides 2 and 100 to start with, and you would still get the same answer if you did it correctly. We talked about that on the 36 example up above. Let's do one more together before I challenge you to try one by yourself. I've got 70. I'm thinking of two numbers that multiply together to give me 70. I'm thinking of 70 and 10. Or I'm sorry, not 70 and 10, 7 and 10. And 7 is prime, so I can circle it. 10 is not, so I have to break it down. 10 can break down into prime numbers 2 and 5, 2 times 5. So if I write these in order least to greatest from the start, 2 times 5 times 7, I'm good to go. And because all of these are to the first power, there's no exponent form necessarily. You don't have to put the 1's in. There's no necessary, you don't have to. You could. It doesn't change their value, but you really don't have to. The best answer here, the neatest, cleanest answer is 2 times 5 times 7. And if you check it to make sure, it should multiply to give us 70. 2 times 5 is 10, and 10 times 7 is 70, so our answer checks. I want you to try this last one on your own, pause the video, and then restart it to see if you got it right. So 24 is what you're trying to figure out. And when I break down 24, there are lots of different things you could have done. I'm going to break it up into 4 and 6. 4 times 6. Neither of those are prime, so I can break them further. 4 breaks into 2 and 2. Both of those are prime, so I'll circle them both. 6 breaks down into 2 times 3. Both of those are prime, so I will circle both. And I've got 2 times 2 times 2 times 3. When I write that in exponent form, I've got 3 2's, so I've got 2 to the third power, and I've only got 1 3. I can write 3 to the first, but again, the first power doesn't necessarily, it almost makes it look more messy than more neat. So 3 times 3 with no exponent is fine. And notice my bases are in order, 2 to the third times 3. I've got my multiplication symbol between them. And I can check my answer really quickly by saying 2 to the third power is 2 times 2 times 2, which is 8. And 8 times 3 does equal 24. So my answer seems reasonable and makes sense. So today we worked on using factor trees to help us find the prime factorization. The name kind of helps us figure out we're trying to find prime numbers. Factorization means multiply. Factor is one of those multiply by words, so we know we're multiplying prime numbers to get to the final answer. And this helps us do a lot of different things in math. It's kind of one of those just baseline skills that will help us later on as we try and find other parts to math.